So you've looked at a lot of new vocabulary today, all related to different segments and angles inside of or touching or intercepting a circle. So just to summarize all of that information, I'm going to go over the different types of angles that you've just learned, which are related to the segments as well. So let's start with a central angle. So I have a circle here. This is the center. A central angle has a vertex at the center of the circle. So I can extend out 2 radii. Each of these is a radius of the circle. And when I do that, I've created a central angle. So in purple, this here is a central angle. Notice the vertex of that angle is the center of the circle. Now if I have instead an angle with, let's do it over here. An angle with a vertex that's on the circle itself. So if this is going to be the vertex of my new angle, I can extend that something like this. So I've created 2 chords here. This is a chord because its endpoints are on the circle. So a chord is a type of segment that has 2 endpoints that are on the circle. So this angle I've created from these 2 chords with a vertex on the circle, this angle in brown is called an inscribed angle. The vertex is on the circle. Central angle, the vertex is the center of the circle. Okay, and then finally, let's, the best we can, create a circumscribed angle. So a circumscribed angle is actually outside of the circle, but it's created by 2 tangents that just barely touch the circle. So a tangent to a circle, again, we're not talking about tangent for SOHCAHTOA and right triangle trigonometry. This is different. Tangent here means that it's just going to barely touch the circle, but not actually go through in another point. So that's how it's different than a chord. So let's say at this point, I draw a tangent here, so it's just barely touching that point. We'll extend this a little bit, and then let's draw another tangent. Okay. So these 2 tangents intersect at this point outside of the circle. This angle here that they're creating is called a circumscribed angle, so it is outside of the circle. So notice the entire circle is really inside of the circumscribed angle if we follow these rays going out from either side.